What is an atom? An atom is the smallest unit of matter that retains the properties of an element. It is composed of three types of subatomic particles: protons, neutrons, and electrons. Protons are positively charged particles that are located in the nucleus, or central core, of an atom. Neutrons are uncharged particles that are also located in the nucleus. Electrons are negatively charged particles that orbit the nucleus in shells or energy levels. The number of protons in an atom's nucleus determines its atomic number and its chemical properties, since the number of protons determines the element to which the atom belongs. The number of neutrons can vary within a single element, leading to the existence of isotopes. The number of electrons in an atom also determines its chemical properties, since electrons are involved in chemical reactions and the formation of chemical bonds. Atoms can combine with one another to form molecules, which are the building blocks of matter. The properties of molecules are determined by the types and arrangements of atoms that make them up. As I mentioned before, atoms are composed of three types of subatomic particles: protons, neutrons, and electrons. The protons and neutrons are located in the nucleus at the center of the atom, while the electrons orbit the nucleus in shells or energy levels. The number of protons in an atom's nucleus determines its atomic number and the element to which it belongs. For example, all atoms with 6 protons are carbon atoms, and all atoms with 1 proton are hydrogen atoms. The number of neutrons in an atom's nucleus can vary, resulting in isotopes of the same element with different atomic masses. The electrons in an atom are arranged in shells or energy levels, which correspond to different levels of energy. The first shell can hold up to 2 electrons, while the second and third shells can hold up to 8 electrons each. The electrons in the outermost shell, also known as the valence shell, are involved in chemical bonding and determining the chemical properties of the atom. Atoms can combine with one another to form molecules through chemical bonding. The two main types of chemical bonds are covalent bonds and ionic bonds. In a covalent bond, atoms share electrons in their valence shells, while in an ionic bond, one atom gives up an electron to another atom to form ions with opposite charges that attract each other. Overall, the structure and properties of atoms are important for understanding the behavior of matter at the atomic level, as well as for understanding the properties and behavior of the elements and compounds that make up the world around us. In addition to protons, neutrons, and electrons, there are other subatomic particles that have been discovered and studied, such as quarks, muons, and neutrinos. However, these particles are not present in atoms under normal conditions and are not directly involved in the chemical properties of elements and compounds. The size of an atom can vary depending on the element and its atomic structure. The diameter of an atom ranges from approximately 0.1 to 0.5 nanometers, or about 1/10 billionth to 1/2 of a billionth of a meter. The size of an atom is determined by the arrangement of its subatomic particles, as well as by the forces that hold the particles together. The properties of an element are determined by the number and arrangement of its subatomic particles. For example, the number of electrons in the valence shell determines how easily an atom can form chemical bonds with other atoms, and the number of protons determines the atom's charge and its ability to participate in chemical reactions. The behavior of atoms and their interactions with other atoms and molecules can be studied using a variety of techniques, including spectroscopy, X-ray crystallography, and electron microscopy. These techniques allow scientists to study the structure and properties of atoms and molecules at the atomic scale. Overall, the study of atoms is essential for understanding the behavior of matter and the properties and behavior of the elements and compounds that make up the world around us. The study of atoms and their behavior is an important part of several branches of science, including chemistry, physics, and materials science. Understanding the properties and behavior of atoms has led to many technological advances, including the development of new materials, drugs, and energy sources. Atoms can also be manipulated and controlled through various techniques, such as ion trapping and laser cooling. These techniques have enabled the study of individual atoms and have led to the development of new technologies, such as atomic clocks and quantum computers. In addition to their role in forming molecules and compounds, atoms can also exist as individual entities, such as in the form of noble gases, which have complete outer electron shells and do not readily form chemical bonds with other atoms. Atoms can also exist in excited states, which occur when electrons absorb energy and move to higher energy levels. The behavior of atoms is also affected by their environment. For example, atoms can be influenced by external forces such as electric and magnetic fields, and they can interact with other atoms through various types of interactions, such as van der Waals forces and hydrogen bonding. Overall, the study of atoms is a fascinating and important field of science that has led to many discoveries and technological advancements. By understanding the properties and behavior of atoms, scientists can better understand the world around us and develop new technologies to improve our lives. Atoms are incredibly small, with diameters ranging from 0.1 to 0.5 nanometers. Despite their tiny size, atoms are the building blocks of matter and are responsible for all the properties of the materials around us. The behavior of atoms is governed by the laws of quantum mechanics, which describe the behavior of particles on a very small scale. These laws can be quite different from the laws of classical physics, which describe the behavior of objects on a larger scale. Atoms can emit and absorb light in discrete units called photons. This behavior is the basis of spectroscopy, which is a powerful tool for studying the properties of atoms and molecules. The study of atoms has led to many important discoveries, including the development of the periodic table of elements, which organizes the elements according to their atomic structure and properties. This has been a critical tool for chemists and other scientists in understanding and predicting the behavior of different elements and their compounds. Atoms can also be used for a variety of applications, including in medical imaging and cancer treatment. For example, positron emission tomography, PET, scans use radioactive isotopes that emit positrons, which combine with electrons in the body to produce gamma rays that can be detected and used to create an image of the body. Overall, the study of atoms is a fascinating and important field of science that has led to many discoveries and technological advancements. By understanding the properties and behavior of atoms, scientists can better understand the world around us and develop new technologies to improve our lives.
Are you curious about something? If there is anything you would like to know, let me know in the comment section below. Let's learn together. If you like the video, don't forget to subscribe for more information. Thanks for watching.